All right. Good afternoon, everyone. My name is Michael DeRose. I'm an ECC engagement manager with Rapid SOS and a very good friend of Tracy's. So I understand she had to be out this afternoon, so I'm filling in for her as I usually do. And I typically teach this particular section in the ENP study group because I used to do a lot of radio and emergency management stuff. In fact, my degree is in emergency management. And I used to manage a radio system. So I have about 17 years in public safety, starting way back in 2005, all the way from as Tracy would say, the baby dispatcher level, all the way up to the director level at a couple various agencies here in Northwest Arkansas. So welcome to the week 3 of the NENA ENP study group for fall 2022. All right. Rapid SOS is a sponsor of Tracy's ENP study group. So if you have not heard of Rapid SOS before and you would like to know more, don't hesitate to reach out later today, at the end of the session, if you have any questions. I cover the state of Arkansas, Texas, and Louisiana for Rapid SOS. So if you live in one of those 3 states, I'd love to, and if I have not met you before, I would love to connect maybe before we get finished this afternoon. So in the interest of time, we'll just go ahead and jump into it. Also want to mention there are 7 ENP exam scholarships available. Get with Tracy for more on that. And there is the application link on scene first/scholarship. And as you can see, the deadline to submit is August 5th. So just a couple weeks away. So if you're going to apply for that, do not forget to get it in on time. And these are some of the sponsors for the scholarship: Rapid SOS, of course, NGA, Prepared, Responder Services, and the 911 Training Institute. So make sure you give all those sponsors some good love at the end of this. All right, so this week's lesson is on public safety radio communications, and we're just going to dive right into it. Without having met all of you, I'm not really sure what your LMR experience is. You might just know that you push to talk, release to listen. That's typically enough for most people. Or you might be like me and have maintained and installed multi-million-dollar radio systems all over the country back in a previous job before I was here at Rapid SOS. So lots of stuff to do with radio. We depend on every day. It truly is one of those mission critical things that we have to make that we have to have for our ECCs to work. All right, so public safety LMR, or land mobile radio. Everything that you have right now is most likely LMR. This can be VHF. There's all types of different systems, and we'll get into those as the slides progress here. But LMR has really been the rock steady form of communication for public safety for the last, I couldn't even tell you how many years. It is public safety grade most of the time. And, everything that we're going to learn today is going to help us understand more of how those radio systems work and what we can do to use them even more effectively. So in a radio system, voice is converted to electrical energy. Another way to think of it is light. Radio waves are nothing but light waves that you can't see. It is an energy wave. It's literally light, but it's invisible. The length of the wave is dependent on the frequency generated, and it's just depends on what type of transmitter you're using. Is it a VHF or very high frequency transmitter, a UHF or ultra high frequency? Could it be 700-800 megahertz? There's so many different flavors of radio systems out there, and it's really important to understand the key differences between all of them, so you can select one that is going to work best for your organization, your topography, your geographical location, the weather. All of those different types of things can go into the selection of a new radio system. And it's also important to understand all of those factors if you just happen to be responsible for maintaining the radio system. So very powerful knowledge here in week 3. One of the other things is, as far as the test, some of the concepts that you're going to learn today are accurate, in so much as being, accurate in concept, but the way radio systems really work today, there are some intricacies that are not necessarily captured in the ENP study material, and that's fine. You're in this course because you want to pass the test. If you want to be a radio expert, you're going to have to go well beyond what we're going to learn in this, in this particular study session today. So you can always get more knowledge. You can always, get deeper on radio systems. But what we'll talk about today will give you a very good basis, and you should be able to pass the ENP exam with flying colors, at least for the radio communications section. I can't speak for Tracy's instruction, but I'm guessing it's probably even better than mine. She's been doing it for a long time. So I'll get you through though. All right, radio waves. As I mentioned, they're electromagnetic waves that travel through the atmosphere. And again, it's an invisible form of light. When voice is converted to electrical energy, as I mentioned before, the wavelength is dependent upon the frequency. So if you've looked at any of your agency's radio licenses, it's going to have a frequency on there. It could be 453.4 megahertz. That's actually the main channel for the original old radio system that I started with back in 2005 at the city of Springdale. I've still got these numbers memorized. Or it could be, a number much lower, it could be 146.2, that's down in the VHF range, or it could be a 900 megahertz system. There's as I mentioned, there's just so many different flavors. And the reason why there are those different frequencies is waves travel various distances based on their wavelength, based on their frequency. So if you're in a very open, rural environment, a VHF system might be perfect for your agency because those radio waves travel long distances without necessarily having to be repeated. If you're in a very urban environment, you probably need a 700-800 megahertz simulcast system with multiple sites so you can beam enough radiation into these buildings so you can talk. It just depends on the topography and all those different intricacies of how you're going to be using the system. So bands, you probably understand or have some type of basis for what all the bands are. But when we talk about VHF, UHF, 700-800 megahertz, all of those things, those are the different bands. It's a subset of all of the radio frequencies that exist. You can go to the FCC website. They have this huge graph with a whole bunch of lines on it and all kinds of different colors. It looks extremely confusing, but it will actually give you kind of the breakdown of all of the spectrum that we're able to use in this country, whether it's for public safety communications or, AM, FM radio, TV, satellite communications, microwave, all of these things. It's all on the spectrum, and you can go in there and study, anything and everything that they have to offer. A lot of the spectrum out there is already kind of spoken for. Wireless, cell phone companies own a lot of it, TV companies own a lot of it, but there is still spectrum available out there, and it's a really complicated and really anxiety type process to go out there and find spectrum when you're trying to build a new radio system. All right, so frequency. I'm not going to read these slides to you word for word. I don't want to insult anybody's intelligence on here, but the frequency, that basically represents the oscillation rate of the electromagnetic radiation spectrum. So that's just how the waves work. And they can range from 300 gigahertz, which is way up at the top, all the way down to 9 kilohertz, which is way down at the bottom. Now, there are lower frequencies than that. VLF very low frequency. That's something you would use underwater, like submarines would use VLF. So there's more spectrum than what we talk about right here, but for the purposes of the ENP test, this is really what you need to know right here. As I mentioned earlier, radio waves do travel at different distances. And again, this is based on their frequency and the length of that wave. Some of them will penetrate buildings better. Some of them will not. Some waves will penetrate a concrete building better than a wooden structure and vice versa. Again, there's so many intricacies that you have to understand to kind of get the right radio system for your situation. But in general, the lower the frequency, the greater the distance of travel. But that doesn't mean that everybody out there should just go get a VHF radio system. It may not work correctly for the way you're trying to use it. So again, lots of different aspects that have to be considered. Then you have your various types of radio systems. The most common is the analog radio system. It uses the voice's vibration to basically change that voice into an electrical current and transmits it across the airwaves. Digital, which is the vast majority of new radio systems that are being built and installed today, your voice is actually converted into little IP packets, ones and zeros. It's basically computer code. So it encodes it into computer language, transmits it, and then the receiving radio decodes it and turns it back into voice. So what you hear on a digital radio system is not your true voice. It's been encoded and decoded once. Analog, it's your true voice. And where you might notice this, if you're out there, maybe your agency used to have an analog radio system and they've somewhat recently upgraded to a digital radio system, you're going to find that where you could kind of use your spidey senses and detect the stress or anxiety in an officer's voice if he or she is in a bad situation out in the field. On a digital radio system, those tone of voice cues and little intricacies like that are so much harder to detect because that voice has been digitized and then decoded back at the radio. So that is one downfall of a digital system. You can't quite get, that true sense of how that person is feeling on the other end of the radio because that's not their true tone of voice that you're hearing. But digital radio systems provide for a whole lot more capacity than an analog one. So there are gives and takes, and your agency really just, they'll need to figure out what is most important to us. Is it, being able to hear the fine details in somebody's voice, or is it capacity so everybody has enough room to talk, right? So lots of trade-offs, lots of stuff to think about. Trunk radio systems, and this, getting into the digital radio systems, this is really where that type of technology shines, because with a trunked radio system, you can have a limited number of radio frequencies and you can use them much more effectively, because when you key up to talk, it may use this frequency pair this time. You release the mic button, somebody else talks, it might use a different frequency. And then when you key up again, you're having the same conversation on the same talk group, but it may be transmitting on a completely different frequency. And all of that is completely transparent to you. It doesn't matter to you. It matters to the system, because it's going to find the frequency that is going to sound the best, that has the most capacity, all of these other things. So trunked radios really add a whole lot of capacity and flexibility to the public safety radio system. And that's why I would say the vast majority of new systems that are installed these days are digitally trunked systems. I don't know why a particular agency would want to spend money on a new conventional analog system. That really doesn't make sense to me, but it may make sense to somebody. But digitally trunked radio systems, wave of the future, that's where we're all headed. As I mentioned, conventional radio systems, you switch the channel, you switch the physical frequency pair every time you turn that knob or press that button to change channels, because at that point you are selecting the exact frequency that you're going to talk on. So all that capacity enhancement and flexibility that you have with a trunk system, it's all gone with a conventional system. As the slide mentions here, yeah, it's slowly being replaced by trunk radio systems. We're only limited by the money we have. Tax dollars are hard to come by. I don't know about you. I don't necessarily want to pay more taxes. So, the replacement of old, outdated radio systems is slow, but it is most assured, and hopefully, someday we can get everybody in the country on a trunk system, and we have much more interoperability for when something bad happens and we need to talk to people, agencies that we don't normally talk to. All right, and here is just a graphic that explains the conventional versus trunking. Over here on the left, you have your conventional system. You see the 2 fire trucks are communicated on channel 1. You have 3 ambulances communicated on channel 2, and nobody is using channel 3. But in a trunking system, you can use any channel that's available at that particular moment in time. The system picks the channel based on the capacity and all of those things. So it's a much more efficient use of the limited radio spectrum that we have. All right, VHF versus UHF. Again, VHF, a longer frequency, so it's going to travel farther, like we talked about earlier, but it might not necessarily penetrate buildings, so you can get that indoor coverage that you need. So if you're in a more urban or even a suburban environment, UHF might be the best frequency band to use. It all depends on the topography and everything else that you have to consider when putting together a radio system. But this is a physical representation of the actual difference between those waves. As you can see, the ultra high frequency, the wavelength is shorter. The distance between the peaks and troughs are much shorter than in a VHF wavelength. All right, very high frequency. So these are, it's 39 to 72 megahertz. If you're familiar with that, a lot of municipalities continue to use these for intercity communications. It's kind of not necessarily a backup, but just kind of a sideband that you can use for intercity communication. So a lot of cities still have those. Some of them have just completely turned them off. It just depends on the use case. However, VHF is subject to atmospheric skip, and if anybody in here has ever played with like a CB radio or even some types of amateur or ham radios, you can get atmospheric skip. So your radio waves are bouncing off the ionosphere, coming back down, very far from where you are. In a straight line, the radio signal would not propagate that far, but when it hits the atmosphere, and technically it's the ionosphere part of it, it'll bounce back down. And so, in fact, I can remember when I was a little kid, I got really interested in CB radios because my dad bought a truck that had a CB in it. And so what did I want to do? I wanted to go to the CB shop and get a base unit for my house so I could talk to my dad while he was driving around in this truck. And when we went to the store and we talked to the guy, and we ended up picking one out to buy and everything, but he was telling me with his CB rig, and granted this was back in the late 90s, so it's I'm sure it's a little bit different now, but this guy had a CB radio set up, and the atmospheric skip was in such a way this particular day that he was talking about that he was able to, from Northwest Arkansas, talk to somebody in Australia. Literally talk to somebody on the other side of the world in the southern hemisphere from Arkansas with a little CB radio. That doesn't happen every day. It's very neat concept to think about, but it just gives you a few things to think about as far as how these radio systems actually work. I can talk from Arkansas to Australia, using a couple $100 CB radio. That's a pretty big deal. So lots of stuff to learn. If you're a nerd like me, you might study up on it a little bit more. But for the purposes of the test, these are the things here on the screen that you really need to know. VHF high band, which is the most common subset of VHF spectrum used by public safety, and that is in the 150 to 170 megahertz range. That's I don't think that's a test question anymore, but that is a good thing to remember, is that 150 to 170 megahertz range. And then you have ultra high frequency. This is the type of radio system that I started out with back in 2005. As I mentioned, that frequency earlier, I think it was 453.4 was, yeah, that was Springdale's Police Channel 1. UHF, it does include 7, 8, and 900 megahertz. So technically, even your brand new Motorola 700-800 megahertz system, technically that is UHF. Okay. But when we talk about it, even radio manufacturers that will, like Motorola and I think L3 Harris make a tri-band radio. So you can talk, and they put on the box, on the label, on the literature, everything, that you can talk on VHF, UHF, and 7-800. Well, technically the 7-800 is UHF, but the way they've had to market it as a departure from your, just regular, 400 megahertz UHF spectrum that people have used so much, or organizations have used so much, they've actually had to market it as something other than UHF, even though it technically is still UHF. So a little neat little bit of information there. All right, mobile radios. So these are the larger radios that are able to transmit at a higher power, but they're installed in a vehicle. And that does a couple things. One, it gives you a whole lot more options with your antenna. So you can have a larger antenna than on, say, a little portable radio. And you have much more power. You've got it plugged into a 12-volt car battery, and that battery gets recharged all the time that the vehicle's running. So you can use more power. And what that does for you is not only gives you better reception, better range, back into your radio system, but it also lets you run several other various accessories. So you can run, maybe in-band GPS over your mobile radio, or you can hook up a external speaker to it. So there's a lot of benefits to having a mobile, other than longer battery life, because it's connected to a car battery. Portables, obviously we know about those. Most of them will transmit at up to 5 watts. I'm assuming 5 watts is probably the OSHA regulation for radiation consumption on a person's body every day. So that's why you're limited to 5 watts, and you have a much smaller battery. So you have, a much more finite amount of power that you can use. So you can't be transmitted in high power. You'll run your battery down extremely quickly. Also, the antennas are smaller, and if you're wearing it on your belt, your body actually absorbs some of that radiation. And I use the term radiation very loosely because that's the truth. That's exactly what it is. That doesn't necessarily mean to scare you, but that's what it is, and your body absorbs that. So that's why radio companies, again, like Motorola, E.F. Johnson, Kenwood, Harris, all those folks, when they design their new radio systems, they don't design it so just the mobile radios can talk. They have to design it down to the weakest of the portables and make sure that those portables can talk in whatever their contractual obligation is. Typically it's 96, 97% of a given jurisdiction has to be able to, you have to be able to communicate with a portable on it. And that's how these radio systems are built. So a lot of limitations with the portables, but they have one key advantage, and that's you can take them anywhere and they don't have to be plugged in all the time. Repeater systems. So these are what we put on the towers, and all it does, it has multiple antennas. It has a receive antenna and a transmit antenna. Usually the receive antenna is at the very top of the tower, and the transmit antenna will be separated from the receive with both height and horizontal. So that antenna is going to be away, and that way you don't get crosstalk and all kinds of problems with the antenna. And it just takes the frequency that the portable or whatever radio is talking to the system, it takes that information and repeats it at a much higher power, typically on at least one or more alternate frequencies. So, for example, you might have a 12 site simulcast system in your city. And what that means is every time somebody keys up a radio, not just the closest tower that radio is connected to is lit up and transmitting. The whole 13 or 12 or 13 site system is lit up and transmitting the exact same voice at the exact same time. And that is what allows you to get that good in-building radio signal. So, you could be down in a base, well, nobody guarantees that it will work in a basement, but you could be well inside of a building and still have this radio be able to talk back out to the system. And that's what is really important about repeater systems, that it allows you to get your signal into somewhere where it normally wouldn't go if you were just communicating radio to radio. All right. One important concept here is the talk around channel. So, you may have a fantastic radio system. You have all your talk groups, everything's nice and organized, but sometimes you just have a couple guys or girls out in the field that, they're on a special assignment and they just need to communicate within their little group and not necessarily have everybody or dispatch listening to them, not because they're trying to hide anything, right? But, they're directing traffic. That doesn't need to be on a main channel. That just takes up space, right? So they can put their radio in talk around mode. And at that point, each radio is just communicating with each other on their input frequency. So it kind of cuts the repeater out of the mix. They can still hear each other, but nobody else can. And so that's a very important feature to have on your radio systems. And it's also mentioned in the test here. So it's really, as the slide mentions, it's kind of like a walkie-talkie mode. Okay, now here's my favorite, and by favorite, I mean my least favorite slide of this whole presentation. I'm going to read it out, and then I'm going to explain why it's not necessarily accurate. So the slide says satellite receivers provide another way of achieving greater signal reception, receives the signal from a portable or a mobile, and the controller selects the best audio signal coming from the satellite receiver that has the highest quality of signal. This entire slide is completely wrong. Okay. The satellite receivers that this slide is actually talking about is just a GPS clock. It's literally a rack mounted clock that connects to a GPS antenna. And all it does is get the time of that particular radio site accurate and synchronized with all of the other radio sites. And this is important in a simulcast system. As I mentioned earlier, simulcast systems where all the radio towers light up and talk at once, for the same conversation, so you can get that good reception inside of a building. If all of those towers don't start transmitting at the exact same millisecond, there is the chance for a whole lot of distortion and feedback and just problems with the sound. So you have to use these satellite receivers. They're from a company called Spectracom. The product is actually called a net clock, but it's just a GPS clock. That's literally all it is. And with that, yes, if you have that, if you have a simulcast system, chances are it has GPS clocks in it, and that allows you to have greater signal reception. This satellite thing here, I frankly feel like it's completely misleading, because you're not using satellites to communicate. You're just using the satellites to synchronize your time. So for the purposes of the ENP test, please memorize this verbiage you see in front of you on your screen here, but just know that this is not how it actually works in the field. Okay. And a voting system is completely different from what we're talking about here. So again, this is my little pet peeve because this, the concept and everything on this slide is completely misleading. But unfortunately, for the test, this is the way you need to learn it. If you want to know more about satellite receivers, GPS clocks, all of this stuff, get with me after the session and I'll tell you everything you want to know. But just know that this one's a little bit misleading. All right, and yeah, so here it is, simulcast, transmit the message over one or more transmitters at the same time and allows for a robust, widespread system. Yes, that's exactly why you need those GPS clocks that we talked about on my soapbox just a minute ago on that last slide. All right, radio over IP. So this is a really neat concept. It's great for administrative types that, maybe they don't need to carry a radio everywhere. Maybe it's a detective division. They don't need to have that big bulky radio all the time when they're going out. Maybe occasionally they drive up, on a scene and they need to get a hold of a regular patrol officer. They can use their phone. There so many radio manufacturers have apps now that you can tie into your radio system. So I know L3 Harris has one. It's called Be On. You open up the app and you can talk on your radio system from anywhere in the world. As long as you have internet, you can talk on your radio system from anywhere in the world, just like you were at home with your portable, with regular radio coverage. The problem with radio over IP is it is not necessarily public safety grade or what we call mission critical push to talk. It's still such a new technology. It's not foolproof yet, and it can break. And the reason why we don't recommend radio over IP for frontline officers and paramedics and firefighters is it has a much greater propensity to fail at the worst time than just a regular old public safety grade portable or mobile radio. So fantastic for little subsets of folks, chiefs, detectives, things like that. But your frontline people need to have a solid public safety grade portable radio.
How to access the Emergency Response Data Platform. Any public safety agency can access life-saving emergency data through the RapidSOS Emergency Response Data Platform. There are two ways of doing so. RapidSOS Portal is a powerful web-based tool that enables you to manage emergencies and access location and supplemental data for every call in your jurisdiction. Signing up for RapidSOS Portal is easy and only takes a few minutes. In addition to emergency management tools and data, RapidSOS Portal includes a training platform as well as administrative tools to manage user permissions, track usage, and analyze trends in your agency. To learn more and sign up for RapidSOS Portal, please visit rapidsosportal.com. RapidSOS also integrates with every major CAD, CPE, mapping, or other public safety softwares. With an integration, you can receive RapidSOS data through your existing workflow, and you won't need any additional screens, tabs, or windows. To learn more about integrations, visit rapidsos.com/public-safety-partners.
All right, now we'll get into a little bit of emergency management. Just real quick, I do have the chat open. Does anybody have any questions on the radio section before we move on? I think we're doing pretty good on time. So do we have any questions before we move on? Watching the chat. Okay, all right, we'll go ahead and move on. So emergency management, lots of stuff to learn here. We have various different types of disasters. You have your local, you have localized disasters. These can be severe weather, floods, tornadoes, regional disasters, so your hurricanes, wildfires, earthquakes. You can have PSAP or ECC only disasters, and that can be a denial of service attack. And I'll tell you a story about that one in a moment. Could be an arson, could be vandalism, or you could just have, unintentional disasters like a telephone or fiber optic cable cut. I've also lived through a couple of those, and I could probably tell you a few stories there as well. Slide not advancing. There we go. Okay, so phases of emergency management, and we'll go through all 4 of these in detail, but I'll just kind of read them out to you real quick. So we have mitigation, and that is activities designed to limit the impact of future disasters. And this is an often overlooked, but definitely undervalued phase of emergency management. I feel like if we would just be more proactive and do more mitigation things out in our jurisdictions, we could probably eliminate a lot of problems before they happen. Of course, then we have preparedness. So this is all your activities, public education, things like that, where you're working on being prepared for an emergency. So, in a county emergency management situation, this could be working on your EOP or emergency operations plan. And it's a customized plan to that county to kind of outline every, if this, then this. We have this type of disaster, our 911 center is damaged. We are going to evacuate in this fashion. We're going to take these people and these things with us, and we're going to go here, and we're going to do this, this, and this. Everything is pre-planned and thought out. So that way, when something really bad happens, we're not trying to figure out what to do. Planning for a disaster is not something you do in the middle of one, you plan before one. So if we have all of these carefully laid out plans and make them easy enough to follow under stressful situations, we just take our list and we're like, okay, we're going to evacuate, we're going to do this, we're going to do this, and in this order. And it makes it so much better and quicker when time really counts in the middle of a disaster. Response, this is when we actually put those plans to use. Okay, we've had a fiber optic cable cut. Our dispatch center is completely dead in the water. How are we going to act? What are we going to do? Are we going to go to a neighboring jurisdiction? Are we going to transfer our 911 lines? Can we transfer our 911 lines on our own, or do we have to call the central office because the break is between them and us? So it doesn't matter if we flip our transfer switches in our back room, they're not connected to anything anymore. So how are we going to accomplish these things we need to accomplish? And we need to train on those. We need to be very familiar with those. And then recovery. This is after the initial disaster is over. We've got the fiber optic re-spliced, everything's happy. Now, how are we going to demobilize out of our backup location and move all of our staff and all of our stuff quickly and efficiently back into our regular full-time dispatch center? So if you have all of these plans in place and you train on them and you continually review and improve them, you are going to have a much easier and less stressful time when your PSAP or ECC goes through something like this. And I have been through 2 of them, and I'm just about to tell you about them when we get to the response phase here in just a moment. So mitigation, all of these things could be, resource planning, supply planning, security, as it says here, physical IT infrastructure hardening, everything we can do to make stuff harder to break. Okay, when it comes to a 911 center specifically, if we're going to do mitigation activities right in the PSAP, this is exactly what we're going to do. We're going to have interagency cooperation plans. So we're going to know, if this type of disaster happens, this is exactly what we're going to do. And everybody knows the expectations. Everybody knows what needs to be done, and we just do it. And we're not all running around in the middle of a disaster like chickens with their heads cut off. That is what we want to avoid. So we need to know about all of these things and more mentioned on this particular slide. Mitigation activities for a different type of organization may look completely different from this. A mitigation plan for like a county assessor's office is going to look completely different. They're not necessarily worried about all this IT stuff. They just need to be able to function and assess people's property while they're not in their building, or while they don't have some of their technology. So mitigation plans are going to be as different as each organization that tries to put one together. More preparedness. So redundancy. Build redundancy into all the systems in your PSAP. So if you can have redundant power systems, redundant network hardware, redundant CAD systems. So, I really hope that more agencies are embracing this idea of a cloud-based CAD. There's also hybrid models out there, where your CAD lives in the cloud, but you have a local server that if that connection breaks, you can fall back on and still conduct business as normal. And then when the connection comes back, all the data is synchronized and everybody's happy. The days of having, one CAD server in your IT room at your PSAP, frankly, those days need to come to an end. We need to be more resilient, because what is going to happen when a tornado rolls through your town and doesn't even have to hit your PSAP? All it has to do is tear up the power lines or the communication lines between your power grid and your PSAP. What are you going to do? You can't pick up that giant server and take it to an alternate location. There needs to be a better way, an easier way of staying on that data, because I can tell you, you go through a disaster, whether it's a tornado or whatever, that is the last thing you want to do, is have to start keeping all your CAD records on paper. I mean, imagine dealing with the stress of not being comfortable in your home dispatch center. Your world is turned upside down. Oh, and by the way, everything you used to do on the computer, you've got to write it down now. Oh, and when all this is over, you've got to put it back into the computer. So there's so much you can do with CAD and in other system resiliency. Do all of this stuff now, and it's going to take, it's going to save you a lot of time, a lot of stress, and a lot of gray hairs, once you go through one of these disasters, if you will just do all this planning and preparedness on the front end versus the back end. You also have to plan for employee health. You have employee assistance programs, critical incident stress management. This is a huge one. I'm glad that we in the 911 world has finally figured out that mental health actually plays a role in how well we do our jobs. We're not just supposed to be stone cold and compartmentalized and just suck it up and come in every day and deal with the public and never let that stress or those feelings out. I'm glad that those days are finally numbered for people. It's okay to care about your mental health, and it's okay to be affected by bad calls that you have. And I know if you're in this group, I know you've heard Tracy talk about those things. I'll just say that she's right. And I think she is helping lead a huge movement that is really going to make public safety communications a better place for all of us, because we're not expected to be just, stone cold, heartless robots anymore. Thank goodness. I'm really glad Tracy's here and she's doing what she's doing, because it is a very important factor in everything that we do in this industry. Even when you're talking about preparedness, even things such as temperature and noise and crowding in your PSAP is super important. I mean, if you've got, and trust me, I've been in some very small PSAPs. I have been in some absolute monstrosities of PSAPs. They come in all different shapes and sizes, and each one of them is just as important as the other. The problem is, in the smaller ones, you tend to get a little bit more cluttered because you have so much stuff that you need, right? You need all your map books. You need your EMD protocol guide cards. You need pens and paper for if you have to evacuate. You need all of this stuff. But what I strongly recommend is, for managers and supervisors and all of these people, go through your PSAP, make sure all of that stuff you have in there is actually useful. Have you picked it up and planned, trained, and exercised with that particular binder in the last 5 years? If not, it's probably safe to get rid of it. The more clutter you can get rid of out of your PSAP, it will actually lower the stress level of you and all of your dispatchers, because you feel like you have more room. You're not constantly trying to keep everything organized. And, if you have, well, I call it CDO, which is OCD spelled alphabetically. If you have CDO like I do, you want your dispatcher to be nice and prim and proper and clean and organized. And if it's just full of clutter, that you don't necessarily use, it can really put a damper on that. And so, make sure your spaces are nice and cleaned and organized, and everything that you have in there is functional and not just something that's going to get in the way when you have some big emergency like this. More preparedness. Yes, mass notification system. So this is a big one. When you have one of these big disasters, how are you going to notify your staff? Are you going to try to pick up the phone and call all of them? What if the cell phone towers are down? So you need to have alternate ways, multiple layers of communication so you can get a hold of your employees and make sure that they know what's going on, what they need to do, what is expected of them, and how they need to handle getting a hold of you if there's a problem. So all of these things have to be considered, and there is not a one size fits all solution. In Benton County, Arkansas, where I used to be the director, we used Everbridge. So we had a countywide mass notification system, and if I had something bad, I even had an app. I could click it and I could page my entire staff in, well, technically less than a minute it would take to send out a notification. Now, if I'm typing a paragraph to them, giving them instructions, it may take a little bit more time, but just getting that message ready, I could have one out to my entire staff in less than a minute if I needed to. Thankfully, I didn't have to do that very often, but just make sure that whatever notification system you're going to use, one, that it works, two, that it makes sense, and three, make sure you test it, make sure it works. If it's something you put in place, you test it once or twice, and then you kind of log out and you don't touch it again until there's a problem. What if your password expired? I mean, do you want to be resetting your password while you're trying to put out a notification that you need all hands on deck because you've just had, some type of mass casualty incident? Is that the time that you want to be worried about resetting your password? So use this stuff, be thoughtful about it, and make sure it's going to be ready each and every time you need to use it. Also have extra supplies, portable radios, flashlights, cell phones, batteries. Those are the obvious ones, but there are some less obvious ones. Make sure you have water for your folks. Make sure you have, maybe some coffee, some energy drinks, some snacks. If you have something bad happen, you've called all your people in, you're all hands on deck, and all you have is whatever is left over in the break room fridge. You're going to get hungry really quick, and people get tired of pizza really quick. So make sure you have those supplies and snacks and everything you need to make your folks as comfortable as they can in light of whatever situation they're dealing with. So you got to be really comprehensive, really thoughtful, and very intentional with all of these preparedness activities that you do. Response. Okay, this is when it has actually hit the fan. When we respond to these things, I'll just tell you a little story about what happened to my PSAP back in 2015. We had just purchased a new call handling system. We bought the new, I think it was Motorola Vesta 4.0 or whatever the latest and greatest Vesta was back in 2015. We bought it. Our county has 6 PSAPs. 2 of them are secondaries, and we just got it installed. Everybody's on the new software. Everybody's taking calls. Everybody's happy. And then one evening, I was driving home, and I get a call from one of the city PSAPs. It was actually the city of Bentonville. And the manager there called me and said, "Hey, I think 911's down. We're not getting any calls. We don't know what's going on." And I ended up, driving to my PSAP very quickly. Good thing I had a Tahoe with lights and all the toys on it. And come to find out that our new call handling system, one of the network cards had some type of malfunction, and it was doing this thing called multicasting. And it's, I don't know, I guess you could kind of use this analogy. So just think of someone like holding a microphone and just screaming into the microphone. It drowns everything out. You're at a concert and they're just screaming into this microphone. You can't hear anything else. Well, that's what this network card was doing to the network. It was screaming at the network so loud that none of the other computers, none of the other servers could really hear anything. And it was making 911 calls drop. The very interesting thing was the federal government actually thought it was a terrorist attack on my PSAP. I mean, my AT&T technicians, they were on this big conference bridge with like 15 different people, including representatives from the Department of Homeland Security. That's how bad this thing was. Turns out it was just a faulty network card that was screaming. They thought it was a terrorist attack. I mean, it legitimately looked like a intentional denial of service attack, and not just on my PSAP, but on my entire county's 911 network. So that was a very interesting night for me. And fortunately, we did have some plans in place to move dispatchers to other locations and spread out and do all of these things. I can tell you at the end of this event, we took that plan and we made it even better with all of our lessons learned. And that's important. You may run into your next disaster next week at your PSAP, and you haven't even had time to take any of the advice I'm giving you today and put together that plan. Just do this. Even if you don't have that plan, even if you have a lot of problems, write everything down. Just learn from those experiences so you know what to do different the next time. So, as long as you learn from those mistakes and don't repeat them, you'll be much better off for it, and your staff will definitely appreciate it, make it a whole lot less stressful. Make sure your policies and procedures are updated. Make sure you plan and train and exercise on your SOPs. And not only that, but share those with your neighboring agencies. If you do have to evacuate and send some of your folks to a neighboring agency, they may not operate the same as you. And your folks need to be prepared for that. They need to be flexible. If they go in there thinking, they're so rigid and this is the only way we can talk on the radio and this and this and this, they're going to have such a stressful time. So if you can teach them to just be a little bit flexible when they go into somebody else's house, if you will, they'll be a lot better off. So make sure all your agencies, I'm not saying all your policies have to match. I'm not saying everybody has to do it the exact same way. Everybody needs to do it the way that best fits their agency, but you've got to have that interoperability, if you will, between different agencies and how they operate during their daily operations. Take all the NIMS courses, 1, 2, and 700 at a minimum. I would recommend taking all of them and go through you can get the professional development series, which is like 100, 200, 300, 400, and then 700. And there's several others. It's been years since I went through the PDS, but go ahead and go through the professional development series with the National Incident Management System. It's all free. It's stuff you can do in your quote unquote downtime when you're not studying for the ENP test, but definitely take those courses. A lot of it is going to kind of make your brain hurt a little bit. You're going to wonder, when am I ever going to use this? But the more of those classes that you go through, you're going to see a lot of recurring themes and kind of how all those parts and pieces work together in the National Incident Management System. So take those classes, try to pay attention, try not to fall asleep when you're going through them. You'll be better off for it. And the other thing is you can put together a telecommunicator emergency response team, or TERT. I'm sure the vast majority of you have heard of TERT teams. I think they are a great thing, and I think they are way, way underused in our country. I think we could do a whole lot better with TERT teams. The problem is you've got a lot of people that are interested in TERT, and you have a lot of people that do everything, they all do things completely different. So it's sometimes it's hard to put these teams together and get everything to kind of mold and form and fit and work the right way. But if you have a really creative and strong leader in charge of your TERT team, you can absolutely be effective and help folks out when they need it. Recovery. So this is what we mentioned earlier. After the disaster is over, how are you going to demobilize your people and bring them all back to your house and resume normal operations, in your house after all this is over? You've got to have a plan for that. It's not as simple as them walking out, driving and getting in their car and driving back to your dispatch center. What about all their equipment? What about all of the calls? What about all the data that was collected and recordings that were collected in your neighboring agency's recorder? How are you going to deal with all that data? If there's a call that needs to go to court, well, yeah, it happened in our jurisdiction, but it's on this guy's recorder over here. So I'm not saying you have to have like a hard and fast policy for each one of these tiny little situations that may happen. But if you have the relationships established with your neighboring agencies, so you can easily work together and call up that neighboring director and say, hey, we're going to court with this call. We need this recording off of your recorder. And as long as you have those relationships, as long as you have the relationships in place, a lot of this stuff will be much easier. It'll just kind of fall into place. So, relationships will fill the gap between all of your policies and procedures and everything else that happens. And then our last slide is that. So that is the end of today's presentation. You've got my email address there. If you have any further questions, do not hesitate to email me. If you want any information on Rapid SOS, if your PSAP or ECC is not a Rapid SOS customer, don't hesitate to reach out there. Also, if you're going to APCO in Anaheim here in a few weeks, definitely stop by the Rapid SOS booth. And I hope that I've been able to impart at least a little bit of usable knowledge on you so you can go out there and absolutely crush the ENP exam. I took it last year, and I think it was May of last year. If I can do it, any of you can do it. So just have a little faith in yourself. Make sure you read through the knowledge guide, read through that blue book a couple of times so you're confident, and then, take everything that you learn in all of Tracy's study sessions, and I guarantee you will absolutely crush the ENP exam, and you'll get to add that awesome acronym at the end of your email signature. So thank you all for your time this afternoon. Again, if you have any questions, don't hesitate to reach out, and I will see you all later. Have a good one.